Good morning. I just wanted to take a moment to talk a little bit about simplifying radicals. Simplifying radicals is going to be a skill that is going to be extremely useful for us as we go forward in geometry, in particular when we start dealing with a lot more triangles. Um, they come up a lot, and it's a really good skill to have going forward in your math career. So, ultimately, our goal of the day is to utilize perfect squares to be able to simplify radical terms. All right. So, there's a couple pieces of information we need to make sure we're clear of. First of all, what is a radical? You've probably seen this before. You might have known it as like the square root symbol, right? So, this symbol right here, this is the radical, this little kind of swoosh going on here, the check mark with the top. Underneath the radical is something called the radicand. And it could be a number, it could be a variable, it could be an expression like x plus 2. It could be all kinds of different things, but that is ultimately going to be the radicand. So if you ever hear the word radical, it's talking about this symbol, and the radicand would be what is underneath it. All right. And you will most commonly see it with square roots. However, as you go forward in math, you could have like a 3 here, which would be the cube root. You could have a 4 here, which would be the fourth root, fifth root, and so on and so forth, as opposed to the square root. Now, another piece of information that is super helpful for us to know is what a perfect square is. A perfect square is a product of two equal integers. So by that we mean 2 times 2, 3 times 3, 6 times 6, 19 times 19, 27 times 27. And these are really going to help you when you're trying to simplify radicals. And the reason behind that is because a square root with a radical, right, will undo a square. Okay? So let me just explain what that means. So if I have something like the square root of 36, okay, or the radical 36, that's the same thing as the square root of 6 squared, right? Because 36 equals 6 squared. Now, the square root and the square undo each other, so they cancel, so that's just equal to 6, all right? So that's the benefit of these. So if you can break something apart into perfect squares and something that's not a perfect square, you can deal with a perfect square. And then you can worry about the other part later. But that's why it's super important. And I'm not asking you to remember all these, right? Like who would remember 29 squared? I don't personally. Um, but I would like you to kind of look back at this chart and reference it to help you. All right. So there's two main methods of simplifying radicals. There's this first method with finding the perfect square, which I think is a little bit easier to follow um, for my personal tastes. The other one is to find prime factors, which is basically factor it into prime numbers like 2, 3, 5, 7, um, 13, so on and so forth. Okay. And then what you would do in this one is you'll group it so that I have two squares, two twos, and then a 3 by itself. That's the same thing as 2 squared, which is why that's 2. And that's the same thing as 2 squared, which is why it's 2. I think that's a little bit harder to follow. So I personally like using this method of finding the perfect square. So we know that 48 is the same thing as 16 times 3. And essentially, one of the properties of radicals is that you can do this. Multiplying, right? It has to be multiplying. This does not work for addition. If you have something like the square root of 4 plus x, that is not, don't do it, equal to the square root of 4 plus the square root of x. Not the same. Don't do that. But it works fine with multiplication. So that'd be 16 times square root of 3. Now, 16 is 4 squared, so it's just 4. All right. So that's why I personally prefer this. I think it's a little bit easier to deal with as opposed to breaking it into these. But it's your personal choice. I'm going to go with this method. All right. So in general, if you're going with the finding the perfect square method, there's kind of a couple steps you should kind of follow. All right. So first you're going to look at your list of perfect squares and see if any divide the radicand, right? So I have my 80. 80. And I'm going to look at my perfect squares. I'm going to see if any of them divide 80. So 1, well, yes, that will, but that won't give me any help, right? 4 will. Okay, so 4 will. Let's think about that, right? 80 divided by 4 is 20. And 80 divided by 4 is 20, so you could stop there. However, you could keep going. A lot of the times, if you're divisible by 4, check and see if it's divisible by 16, right? Why not? It's worth a shot. And as it turns out, it is. Okay, so what do I mean by that? I mean, just kind of keep checking, right? 80 divided by 4, well, that's 20, so that works. 80 divided by 9, if you plug that into a calculator, it's going to be something with a decimal, so that's not going to work, right? If you did the same thing with 25, it's not going to work. 36, it's not going to work. Once you get over half, it's not going to work, so don't try it, okay? So let's look. Okay, so now we have 80. So it is divisible by 16. It is 16 times 5. So I can break this into 2, right? Square root of 16, square root of 5, or square root of 5, right? So what you're going to do after you divide is you're going to rewrite it as 2 radicals, one with a perfect square, one with not a perfect square. And then you're going to simplify the radical with the perfect square, right? That's where we got our 4. And then you would repeat. So what do I mean by repeating? Repeating would be if you had taken the route with the 20, okay? So if I had done this, okay? If I had done this, I would look at this and try again with my chart and see if any of my perfect squares would divide 20. 4 will, so I could do it again, right? 2 root 4, root 5, right? Because 4 times 5 is 20. So then, let me move my head. That would be ultimately equal to 2 times 2 root 5, which is 4 root 5. And that's all I mean by this last step, right? We got to this point, but 20 you can still keep simplifying. So you would go through the process again. All right. So let's go through this. Let's try some. Square root of 75. Well, that one I think has a pretty obvious division, right? That's clearly going to be 25 times 3. 25 root 3. Right, 75, that's clearly going to be close to 25. 3 of them. Root 36, that's easy. You already know root 36. That's just 6, right? 36 is a perfect square. If you get a perfect square, just write it. You're done. Root 80. Well, we did just go through that process, so let's see if we remember, right? It is divisible by 16. And in terms of knowing what things are going to be divisible by what, with time, you do pick up on a lot more. But the other benefit to it is, you can kind of look at it and say, well, clearly 80 is not going to be divisible by 9. Like you can kind of eliminate certain ones. Good ones to try are usually 4. And if you're divisible by 4, try 16. It's worth a shot. Okay. So 4 root 5. All right, now we have root 8. Now, one of the benefits of something small like 8 is you really only have one option. You have 4, and it is divisible by 4, right? Root 4, root 2. So it is 2 root 2. Now, root 8 is going to be a very common one you encounter, so if you just recall that it is 2 root 2, feel free to just write it. Okay, last slide. Do some more for good measure. 64. All right. Well, that's just 8, right? 64 is 8 squared, so we're done. 30. So let's go through our perfect squares. So we have to look at things less than 30. Well, obviously 1 will work, but that'll give me 1 and 30, which doesn't help me. 4 won't work. It seems like it should, but it won't. 9 will also not work. 16 will not work. 25 will not work. And then after that, we're already bigger than 30, so it's not going to work. So no perfect squares can be taken out. So we actually have to say that we can't simplify. It's just root 30. We're just done. All right. You are just done. Last one, root 18. Well, that's definitely going to be 9. And it is 9 times 2. So it is 3 root 2. Now, this is not a super crazy concept. I think you will get the hang of it after you've done it a couple times. The hardest part about it is usually, especially when you get a bigger number, trying to figure out what factors to find, right? What perfect square. Just go through the chart, go through the list, divide, see what works. Try the small ones first. If 4 works, take it out and repeat. Sometimes you'll find a number that you know. Um, if 4 doesn't work, try 9. If that doesn't work, keep going. If something eventually doesn't work, um, you can just leave it alone. You only need to check up to less than half. All right. So what do I mean by that? Right. With 30, I didn't even need to check 16. The reason 16 won't work is because that would make my answer less than 2, which is never going to be a perfect square. Okay. Um, so anyway, let me know if you have any questions and have a great day.